Hydrus, an entirely new concept in commercial and industrial water treatment, is a multi-port valve utilized in ion exchange and filtration applications. Hydrus is fully ported with 2-inch inlet, outlet, backwash, and 2-inch rise tube connections and can be top or side mounted on either steel or fiberglass pressure vessels. It controls service flow, regeneration, and backwash for a variety of applications including ion exchange water softening as depicted in this video. The valve is constructed of an incredibly durable, non-metallic composite formed into serviceable sections that are firmly held in place by stainless steel hardware. This lightweight valve is designed to withstand the rigors of industrial applications and has easily passed 100,000 cycle testing protocols. During service, Hydrus operates in a downflow mode. Water enters the tank and is dispersed through an upper distributor, ensuring uniform flow across the resin bed. In a multi-tank application, once the resin has reached a state of exhaustion, the valve initiates a highly efficient countercurrent regeneration. The first step in a multi-tank countercurrent regeneration is to slowly introduce an upflow solution of brine. Care must be taken not to disturb the bed. Concentrated brine is blended with soft treated water and then added to the bottom of the ion exchange resin bed. Hardness minerals are exchanged off the exhausted resin as the brine moves up through the resin bed. The minerals then exit the top of the vessel and are sent to drain. To initiate regeneration, the Hydrus valve needs only a stream of water supplied by an external solenoid or valve. This solenoid, available as part of a Smart Start control package, signals the hydraulic control flow to start the regeneration. After the short hydraulic signal, Hydrus automatically shifts into the brine draw cycle. Hydrus activates internal pistons as it moves into brine draw. The inlet water is shut off and treated outlet water is used to begin the countercurrent regeneration cycle. Once the required amount of brine has been added to the ion exchange resin, the brine cycle ends and the valve continues with a slow rinse. The brine within the vessel continues its countercurrent travel through the resin as sodium is exchanged for hardness. This step is critical for efficient countercurrent regeneration. The use of treated water for brine draw and rinse prevents contamination of the bed, resulting in much better softener performance as compared to downflow or co-current regenerating units. Countercurrent regeneration reduces salt use and wastewater volumes while simultaneously improving water quality as compared to older, more common co-current regenerating ion exchange systems. During a multi-tank application regeneration, the inlet to Hydrus shuts off to prevent untreated water from entering. Hydrus's outlet port is temporarily converted to an inlet port, so all water used for the regeneration comes from the distribution header and enters through the outlet port. After the slow rinse process, the valve will shift into a backwash cycle. The Hydrus control valve uses treated water to backwash the media. The flow rate increases in the upflow direction to remove light particulate matter that may have collected in the media vessel during service and to reclassify the media. This step helps to maintain a clean, uniform bed of media. After backwash, the valve begins the fast rinse or purge cycle. This brief downflow fast rinse cycle settles the ion exchange bed, prepares it to go into the service cycle, and simultaneously ensures no brine is left in the lower section of the tank. At the conclusion of the fast rinse, the valve transitions back into service mode. At this time, the Hydrus valve automatically emits a hydraulic signal that is transmitted to the next Hydrus valve in the series. This kick next signal is maintained long enough to ensure the next softener tank begins to regenerate. The kick next function ensures that the next softener in the train begins to regenerate at the correct time and eliminates the need for redundant and complex control systems.